Assalamualaikum everyone, welcome to another topic of study with ARS. Today's our topic is escape velocity. So it is defined as that the velocity required to uh, to move away from the move away from the gravitational field of any planet. It may be Uranus, it may be Venus. Gravitational field of any planet, it may be moon itself is a satellite, but we can set it, we can go out of the moon. The gravitational pull is also there, so don't go in the deep. So I will be uh, clearing you this one topic by drawing a bit of bit drawing. Okay, so this one is Earth. Okay, and the radius is this one. And for example, there is a mass on surface, and we are discussing to launch it. And as you know that in our previous video we have discussed that if we have to launch any satellite, then we will be having a projectile motion. Okay, so we are discussing to launch this one. So this is an object, and this is the mass of Earth. This is a mass of Earth, and this is a radius. Okay, so I have said that uh, if this object want to revolve around this Earth, means this satellite, then it will be having a need of speed, and which speed is known as escape velocity. And this velocity is equals to, it will not be called as speed, it will be called as velocity. Okay, kilometer per second, 11.2 kilometer per second. So now you may assume that how much this velocity is required, kilometer per second. Okay, so now we are going to drive the formula of velocity. This one escape velocity. So as you guys know that uh, in the conservation of mass, we have the rule increase in kinetic energy equals to decrease in potential energy. So for kinetic energy we are having the formula of half mv square equals to, now for going for potential energy, decrease in potential energy, so we will be writing delta potential energy. So for finding delta potential energy we are having this one formula equals to potential energy final minus potential energy initial. Okay, so as you know that when this object will be going upward, it will be means it is there, then it will be having no output, means it will be going there because it is out of field. Now gravity will not be attracting towards this side. Okay, and now it is there, and now its energy has been loses. Now it will only revolve around the earth because of gravitational pull. Okay, I might think that you are understanding. If you are not, then um, means watch from the previous. Okay, so potential energy is equals to, as I have said, there will be no potential energy because it is only revolving. Its own energy become here zero. Okay, this is revolving because of the gravitational pull. Zero minus potential energy initial. What was the initial potential energy which we was giving? We was giving this potential energy opposite to the gravitational force, so it will be called as minus g m upon r, and this is the mass of Earth, this is the mass of that one object which we are sending. So it will become delta potential energy become equals to this minus will be multiplying with this, so this bracket is here, so it will become positive g m upon r. Okay, so now putting this the value of g r here in this one equation, in equation a. Okay, so we are putting the value half mv square equals to, instead of delta potential energy we will be writing this g m upon r. So this m will be cancelled with this m, so when this 1 upon 2 will be moving, it will hold moving, just v square will be there, and v square is a escape velocity, esc. Okay, because we are discussing about escape velocity, so we have to write this one, esc equals to what will become 2 g m upon r, 2 gm upon r will be there. Okay, so if we have to find the value of v, then we have to take a square root on both sides. Okay, so v escape equals to 2 g m upon r. So there is one more formula. This is also a formula, but if we are still driving it, then as you guys know that force is equals to g m1 m2 according that one law from Newton, gravitation law, upon r square. Okay, so instead of force we can write weight is equals to mg equals to g m1 m2. m1 is the mass of earth, m is the mass of object here. Okay, which we are sending, and r square is also equals to r into r, and m cancelled with m, then this will become g, and this r will be shifting here. Okay, then it will become g dot r equals to g m mass of earth upon r. So as you can see that this one g me upon r, and this one is also g me upon r. GME, this is the mass of earth, GME upon r. So we can write this one GME, we can write this one GR here because it is also equals to this one. Okay, so we are putting the value of GME upon r in equation number b. Okay, so here we are putting the value, it will be equal to v esc equals to 2, and instead of gme upon r we will be writing gr. So this is the formula. Hope you guys enjoyed this, and we'll see you in the next in the very next video. Okay.